Hello everyone, myself Sharma. I'm currently working as a software developer engineer in Intel Systems. I'm also pursuing my BTech degree from Thapar Institute of Engineering and Technology in Computer Science. I was given a project on optimizing a multi-core application by my team. First, about my company Intel System. Intel System is a global leader in providing quality control, monitoring, and analysis solution for the digital media. Big companies like NBC, HBO, BBC, Fox, Warner Bros., 25th Century, Amazon, all are a customer base. All are included in the customer base. The company's industry-leading solution includes Beton Caption, Orion Vega, Vino BMP, Beton OTT, and many more. About Beton. Beton is the most important product of our company. Beton is an automated file-based QC system. It implements organizational QC policies to support combination of automated and manual QC check. Beton is used by global broadcast, cable, telecommunication, satellite, IP, TV, and OTT, and post production. So Beton in itself is a big project. Beton includes many applications like Beton checker application, Beton caption, Beton lip sync, um, Beton media player. And I was given a task to optimize checkers application. So Beton checker application is a multi-threaded application that enables the analysis of different type of media files based on the set of checks defined by the tester. Beton checker application is optimized to take advantage of multi-core system to maximize content processing. And here is where I come. So uh, to process our application in multi-core, we first need to divide the file data into individual independent chunks of data so that every core can process every chunk of data independently. So so for this way reason we have to process file reading twice. Firstly for dividing the independent chunk data, and secondly for actual processing of the file. So architecture of our project. So user provides a test plan and location of the file either on premises or on cloud, and we create a configuration file which has information about number of CPUs, file paths, and other configuration info. So parsing of input file is done along with the initializing of decoding engines. So the number of data sources that we create are linearly dependent on number of tracks in the file system, in the file, media file. For example, if a media file contains around 10 tracks, then we have to create around 10 data sources for each track. So after that, it depends on whether we are processing our application using single CPU or multi CPU. In single CPU, it's simply we process all the data and we do decoding and analysis of the stream, and then dump a task. In multi CPU and multi core system, we divide the data into dependent chunks of data, and which we provide it to every core, and then we decode and analysis of the stream by decoding index is done, and after that we dump the task report. So me and my team came up with two approaches. Firstly, for intra-coded streams. So by intra-coded streams, I mean that every frame of the stream is independent of another frame in that stream. So in this case, we can simply, for example, like containers like MP4 and MOV contains metadata, which contains sample sizes and sample offsets. So we can easily use them and make an independent chunk of data for every core. The second method would work on file codecs like HEVC and AVC. So HEVC and AVC like codecs contain I frame, B frame, and P frame, also known as intercoded frames. So in B frame, what happens is like a frame is dependent on the previous frame, and in P frame is in which the frame is dependent on not only on previous but also on the next frames. So these files of file reading can't be done using metadata. So what we do is we first read the first 5,000 or 10,000 bytes of data, because it contains specific header values that we need for decoding the frames. So what I did was I created a data source, and for every frame I read the first 500 or 5,000 or 10,000 bytes of data, and other data from the frame I didn't treat that. What I did was put in garbage like ff value, hexadecimal value in it. Now highlights of the project. Using both method 1 and method 2, like method 1 for codecs like Chorus and DSHD, and method 2 for codecs like HEVC, ABC, we achieved in reduction of file reading by 45 to 50%. So, which in itself is a huge success for us, because if a user has put his or her file in cloud, so now when we process it, earlier he or she has to pay like 100 rupees, for example. Now he or she would be paying only 50 rupees. And another good thing was that processing time was reduced by 33%. Uh, Thank you.